So welcome to the video for this question. Here's the question we're going to be looking at. A particular fruit's weights are normally distributed with a mean of 596 grams and a standard deviation of 15 grams. And we want to know the heaviest 3% of fruits weigh more than how many grams. So let's go ahead and pull up a whiteboard to look at this. Okay, so if I were going to be writing out my work here, because we want to look at not just how do we find the answer, but how do we present the answer in a way so that you would get full credit for your work and so that it's clear. The first thing I want to do is write out the information I've been given and write it in a statistical way. So the way that a statistician would write the fact that the mean is 596 grams and the standard deviation is 15, we can use that shorthand by saying my distribution here is normal with mean 596 and standard deviation 15. And let's begin by sketching out that picture too. So we're talking about a normal distribution. We can always draw that. Oh, that doesn't look good at all. Let's see if I can erase that. Try to get a straight line there. Okay, so let's try again. Just want a pencil. Alright, so here we go. So we're going to draw our horizontal axis. Sorry, this drawing tool is not great. So imagine horizontal axis. Now we're going to draw our curve, our normal curve. Yours will look more beautiful than that, but that gives you an approximate sense of what we're doing. And our mean here is at the value 596. So this is 596. You know what? Let's erase off that extra line so it doesn't mess us up. Oh, things are getting weird. So if we think about what we want to calculate here, they want to know the greatest 3% of fruits. So they want to know, if we think about right here, imagine this area here is 3%, which as a decimal is 0.03. They want to know what proportions of fruits weigh more than that. So they're looking for the number at this spot on the horizontal axis. So if you're writing up your work here to get credit, you would want to include that it was a normal distribution with this mean and this standard deviation, that in your picture you'd want a straight line there, your normal curve, here's the mean labeled. You don't have to label those standard deviations, but you definitely want to shade in the area you're interested, the proportion that corresponds to that area, and then remember the calculator command. If we already know the area we're looking for, and we want to find the value on the horizontal axis, the calculator command that can give us that is a calculator command inverse norm. So that's what we're going to do, and you would want to write that somewhere on your paper too, to say we're going to use the calculator command inverse norm. Remember, when we use the inverse norm calculator command, it's a little funny. It always wants to know to the area to the left of the value of interest. So it can tell us a value we want to know on the horizontal axis, but we have to first tell it the area to the left of that value. So we're going to have to input what this area would be in red here. And how do we find that? Well, we use the fact that we know that for a normal distribution, or for any statistical distribution, the area under the curve is always 1. So this area in red is going to be 1 minus this area over here, which was 0.03. So when we calculate that out, it's going to be 0.97. And that's what we have to enter into the inverse norm command. So our first entry would be 0.97. And then it wants to know the mean and the standard deviation, and we indicated over here that the mean was 596. And the standard deviation was 15. So that's what we're going to be entering into our inverse norm command. So let's go ahead and do that now. If we do second vars, inverse norm is going to be command number 3, and we put in 0.97, and then 596, and then a comma, and then 15, and we do enter. And the number I'm getting there is 624, so my answer is 624. 0.21 depending on how many decimal places were asked for. WAMAP often wants 4, so let's go 0.2119. So that's telling me that for this type of fruit that typically weighs about 596 ounces with a standard deviation of 15 ounces, if you are going to be the top 3% of those fruits, so if you're a farmer and you want to seed, well, is my fruit going to win the prize at the fair for being the biggest? Well, if your fruit weighs more than 624 pounds, or that would be a very big fruit, 624 ounces, you're going to be in the top 3%, so it'll be very likely that you might win a prize. The final thing you want to do, this would be the answer you'd enter into WAMAP, but in your picture, you want to draw that number on the horizontal axis to say this question mark, we found out what it was. It was 624.21. We'll just say 0.2 in this. 624.2 ounces gives us the top 3% of fruit weight.